Good evening, everybody. Welcome to the DCAST presentation, DC Agile Software Testing Group, our March meeting. I'm Stephen Ritchie from Excella Consulting, and we're going to talk about Agile testing best practices. I have a brief agenda here, talk about the motivation behind Agile testing, the principles, and the obstacles that you can face. During the course of the presentation, if you just want to refer to the wall over there, I actually have a little cheat sheet over there of all the things that we intend to cover. Now, I'm not going to be able to bring up code and go in deep on that for the coders. And for the testers, I'm going to talk about a lot of stuff that may, in fact, be things that you'll have to work with your test engineers or your developers about implementing. But what I'd like to do is sort of give you an overview of what it means to do Agile testing. What are some of the things that you'll want to look for, ask for? What are some of the things that you might encounter as problems that knowing about them in advance will help you prepare for them in the future? A lot of this comes out of my consulting work and what I've seen with clients in terms of the obstacles they've faced or the things that have helped them be successful with Agile testing. So the first question I'd like to say is, why are we testing software? Well, there's a classic curve that really focuses on the idea that if you find defects while the software is in service, it costs a lot more to fix them. If you find them in testing before that goes out, it's cheaper. And if you find them in implementation. One of the things that I often get asked is, why is it so much cheaper to find for the developers to find and fix their own problems? Well, usually I say, well, QA tester finds a problem, they write a bug. They write a bug that gets tracked. That gets delivered to a developer who doesn't understand it, has to have questions, steps to reproduce. That's tracked to closure. There's a whole bunch of managerial aspects to it. Typically, when a developer finds their own problem, they fix it quietly and efficiently, and it doesn't get tracked. It just as if it never happened. So it's so much cheaper to do things on the implementation side. What Agile testing is all about is to try and bring an iterative, incremental combination of both the developer learning about the defect and the developer finding and fixing their own defects, and the QA folks that are testing the application being more effective and efficient at getting them resolved without a lot of ceremony that isn't necessarily helpful. Another reason we do testing is because I've worked on software systems before as part of automobiles. And if you're working with mechanical engineers, they say things like, we'll take this component apart and we'll destructively test it and we'll look at the welds and we'll evaluate it and we'll do that type of thing. And they do that for all the things. Eventually they're smashing cars into walls and seeing if airbags are going off, and they're evaluating it in a mechanical way. They look at everything. But when you ask them about software, those same people say, well, I can't observe it. I can't see it. It's invisible to them. And so a lot of the reason we're testing software is because people can't see into it. So we're trying to get a handle on what's going on internally. So the next question is, why write automated tests? I often say automate, automate, automate. And there's a huge movement to do more and more automated testing, and Agile promotes this as well. It's the classic problem that things have changed. And if your focus is on manual testing of software, then you're probably going to find that the software you're building is costing too much, and the quality expectations are not being met. But more importantly, sometimes the software is just so big, there are too many permutations and combinations for the staff that is available. For example, I've worked on health benefit or HR benefit applications but simply the number of benefits and the number of different options in those benefits created a matrix of so many variables that could vary in such large numbers of ranges that it was almost impossible to test the application. So motivations that I've talked about right now are the lower costs and the achieving the desired results. The two things that I want to focus on is people expect higher quality software. At this point, the results are everything gets tested every time. And there's less spot checking and more thoroughness. The other things as a motivation is visibility and insight. And what I mean by this is that Agile looks for tests that allow developers to debug the problem faster, that reveal the exact problem, so that there's a lot less of what were the steps to reproduce that problem. Instead, there's a very specific test that failed. The developer goes in and looks at that test. That test describes exactly what the steps are to reproduce the problem. And it reproduces it every time reliably. So you get greater visibility and insight. The other visibility side is a manageability side. If you started your project and you can watch the number of tests that are being written, gives you an indirect measure of the fact that people are writing tests and that the tests are going up in proportion to the code, for example. It gives a manager a good sense that they had X number of lines of code, now they have 2X. They had Y number of tests, and now they have 5Y tests. Maybe there's a, appreciation of quality. As opposed to they started with Y tests and they still have Y tests, or maybe Y plus 2. It's a very important factor from a managerial perspective because quality is something you can only indirectly measure. This is the reason why each of these pieces, there's things like code coverage and other metrics that give you that visibility and that insight. Another motivation is what I symbolize with the smoke detector, is problem detection. These tests are going to find defects. The defect could be that a developer didn't understand the requirement. It could be that the developer did not do a thorough job. It could be that requirements changed in one part, creating an impact on another part. Whatever it is, these suite of tests are now starting to do problem detection. Agile wants to do problem prevention for early detection. This is another focus. And then the last thing I like to symbolize is the weather satellite, which is an early warning system. One time on a project, I walked in on a December 1, first day of December, and I found a test had failed. Like, what happened? And I went into the code, and I looked at it, and it suddenly dawned on me that they were taking the current month, adding 1, and then using it to input into a date function. Well, the 13th month of the year doesn't quite work. The tests were an early warning that if this code goes into production, it will fail every December 1st. Without that tests, maybe or maybe it wouldn't have been found. So using tests as a way to perhaps look into the future. What happens if we run this in Q1 of next year, Q2 of next year? How can we do some forward analysis? That's what I mean by the idea of an advanced warning system. But fundamentally, one of the biggest motivations around Agile testing and automated testing in general is you want to make sure that the software works as intended and continues to work as intended as much as possible around the outside of the application. In other words, from looking outside of it in all aspects, no matter what we change in one section, we know that the other section continues to work. One module, another module, they're all working as intended all the time. So that's the basic motivation behind Agile testing. Let's talk about some of the principles. This is often referred to as the Agile testing pyramid. And the idea behind this, and there are a lot of variations on this diagram, but you have unit level, developer level tests, and you have integration system level tests, and then as you move up there are maybe automated tests that run at the UI, and then there are manual tests that are exploratory tests that the QA testers are performing. Maybe you have UAT or other ways of testing. All that is in green in this, in the pyramid, represents the automated and the automatable. And the base of this is sort of the proportion here. There should be many more unit tests, and this is a conceptual proportion, not a literal proportion, but unit, integration, UI. And this is where a lot of the engineers and test engineers find themselves in this area, and the testers are going to be up on that top. And by the way, this link right here is going to do the, let me Google you that for you, Agile Test Pyramid. So if you feel it's a little snarky, I apologize. But that will actually do the Google me. Let me Google you that for you. But this is the reality. So that was the vision. But the reality out there is that there's usually very little unit testing going on and very little integration and very little UI. And if it's automated, it's been some sort of experimental effort, right? It doesn't have a lot of breadth of coverage. And this is sometimes referred as the ice cream cone anti-pattern. For those of you who know the Lorax, I kind of consider this the Lorax pattern. There's a lot of manual testing that goes along the top. And there's sort of this very narrow effort to do automated testing. And that really needs to change. And this is known as the Quadrant System. And wherever you see these green triangles is where you want to try and focus on automation. But down in this lower left quadrant, quadrant 1, we're supporting the team with technology to do unit and component testing. And up in the upper left-hand corner, we're doing things that are a little bit more business-facing. They're supporting the team, but it's about functional stories and other agile things that focus on the product owner. And on the other side, it's often referred to as critiquing the product, but somehow we're trying to make the product break or make sure that it's acceptable or unacceptable. So we're going to try and load it up and see if it's going to fail. And we're going to try and attack it with vulnerability scanners and that type of thing. And that we can definitely automate with technology. The upper left-hand corner, that little cloud represents the manual area, the place where we tend to find the most manual testing going on. And this is, again, the principle here is to try and focus on these quadrants 1, 2, and 4 in as much automation as possible, with the understanding that the testers can focus on exploratory testing, which is to go in there and try things out and do things in ways that are new and different. And UAT, where we're going to try and get some users to do some acceptance testing for us. So principle number 1 is that unit tests are about developers. A lot of people wish that the word test had not been included, because many developers say, I'm not a tester. And many people in the QA test side say, testing is a QA tester function. So there's a little bit of antagonism over this, or confusion. I like to say that we should not call them unit tests, but we should say that these are about developers' intention checking. They're trying to make sure that the code they wrote works as they intended it. That's what these are all about. We call them unit tests because that's the conventional name, but the idea is that it's a developer checking to make sure that the code works as they intended it to work. The second principle is automation. Like the Terminator, we need something vigilant. Okay, maybe Terminator 2, that's protective rather than Terminator 1 that is trying to destroy Sarah Connors. But the idea is that it's a focus on being running over and over again with things like continuous integration servers, or that when developers bring down the code, they have an easy way to run all the tests. Or you automate them by having QA be able to get a build pushed out and then automatically run a suite of regression tests. Automation is very important. It's so important, I'm actually going to mention it twice. Continuous integration is a great way to take that automated suite and to use a continuous integration server to run that set of automated tests every time a developer checks in and commits a piece of code. But it's also a great way, and I've done this with clients, to run overnight functional tests, to do a smoke test after a deployment goes out. How many times has the QA team said, you just deployed it, we just ran it, and it blew up? And the developer says, oh, that's because I didn't configure something. Well, that is a diminishment in the relationship between the developer and the testing team. The testing team says, you let something fall through the crack. And the developer team is saying, you know, it's so boring deploying this thing and doing all these manual configuration things. We don't want to do it. The answer is something like a smoke test, right? Or to use the continuous integration to deploy and configure it. But either way, the developer knows right away with the smoke test that it blows up as soon as you try to do anything because it's misconfigured. And then I can go on with all these other things, but the key is continuous integration is a great way to put all that automation into your project. The third thing I'd like to talk about is the idea of zero configuration. And I put the footnote that one-time configuration is okay. If you know, it means setting up a database one time, or putting some registry entries in there, or some environment variables in there, that's okay. The key thing is that every time you run the tests, it isn't a process of, oh, I need to manually configure it because the tests require some changes every time I try to run them. Also, the principle here is I can run your tests, you can run mine, meaning if I'm a developer and I get another developer's tests, I should be able to run them without configuration. Similarly, if QA team is working together, they can run each other's tests, the entire set of tests, all run without needing to be configured by anybody. This is a huge principle because so many teams cannot run each other's tests simply because they don't know how to configure them. Fast is also important here. Long-running tests that take days are simply not going to be acceptable. Unit tests need to be run faster and faster. As they grow, they have to remain fast. Otherwise, developers won't run them. When I say fast, people often ask me, well, how fast is fast? Or how slow is too slow? I usually say to the developers, if you checked in the code and you had to wait for all the tests to run before you go home, how long would that be? How long would be acceptable? And many come in around 5 minutes to 10 minutes. Right? So I use the Friday afternoon test. Many of the QA folks is, I want the tests to run so that when I come in the morning, I can see the results. So they're looking for an overnight suite is often what they're talking about. Some of the clients that I've worked with, the QA testing team, test engineers will work on tests during the day, writing them, putting the suite together, having them run at night, looking at the results in the morning. That's usually the type of time frame they like. But it all depends on those types of things. But whatever that time frame is, they have to run well within that time frame. Clear results. Too many times tests come up with an answer that, and I've worked with teams, I'll say, that test failed. And they said, oh, don't worry about it, just run it again, it'll pass. That's the type of problem that comes out of, or the type of test that makes the whole suite a little bit suspect. When things fail, people should react like, uh-oh, something really went wrong, let's go investigate it. Not, Well, yeah, a certain percent will fail. It just so happens that they ran out of order, or you got to run them twice to see them all pass. So focusing on this. The third one I mentioned here, isolate issues. The key thing is if a test can help you find and fix a problem, it's an awesome test. So if the test fails and you go in and you debug with that test and you find the problem in the code and you fix the problem in the code, that test really saved you a lot. It saved you time writing up the defect, the QA team, tracking it, all that kind of thing. So isolating issues. One of the corollaries to that is you don't want really long tests. Tests that are hundreds of lines long don't help you isolate issues. There's too much going on. Easy to maintain. A lot of this I will focus on in the obstacles discussion, but if from the beginning you think to yourself, I'm going to have to look at this test code 2 years from now, and if I pick it up 2 years from now and I don't understand what it's doing, then I'm going to be in trouble. And here I often talk about, what if your best friend was coming to work to take your job over, or what if your grandmother was going to come in and take your job over? You'd want to have really helpful code. So somebody you care about is going to take over your code. You want it to be easy to understand and not long-winded. The last thing I talk about when I talk about principles of Agile testing is this idea of timeliness. Too many projects have developers writing a lot of code over a long period of time, and then the testers go and test them. And then the developers say, I don't know what's wrong with that code. I worked on it 6 months ago, or even longer. So writing these tests as the application is built, or coming up with automated tests that reproduce problems, help tremendously focus the team. And Agile working in sprint iterations helps that as well, because the tester is focused in there writing the tests at the time the code is being built and keeping and maintaining those tests. It helps find and fix problems at the moment they're written while it's fresh in the mind of the developer. Test-driven development in and of itself as a developer discipline also helps with this entirely, because they're getting fresh tests written as they're writing the code, and it becomes part of a suite that continues to make sure the code works as intended. So those are the principles. Any questions at this point? Does anybody have anything they wanted to jump in with? Okay, so let's talk about the obstacles. So the obstacle I'll mention first is the obstacle of requirements. What are those requirements all about? Recently, I was talking to somebody about the conversion of Fahrenheit to Celsius, or Celsius to Fahrenheit. And we were talking about the formula and the algebra, and it's just verbally talking about, how do you calculate Fahrenheit, Celsius. The only way we could figure out who was right is to start putting down some examples. Well, 0 degrees is 32, and 100 is 212, and we worked through some examples. And sure enough, one of us was right and one of us was wrong. I won't say who was right and I won't say who was wrong, because it was my wife I was talking to. And the key thing is oftentimes things are way too abstract in the requirements. And this is an obstacle to automated testing. Because on one side, somebody's writing a test, and on the other side, somebody's writing code based on some abstract requirements. I'll jump down to the changing requirements, as everybody sees that and feels that one happening a lot. The third one is the overspecification. This is where a requirement says to do something that isn't explicitly necessary. And it kind of ties into the changing. Right? If the requirement describes that given this condition, when this action happens, then expect this result, it's an enduring business process. But when it gets to the very specific, the system shall display the message that says blah, 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 then those can get very difficult to maintain as automated tests. So I'm going to show you a little example here of some code, and hopefully everybody can see this. This is some test code, and what it's going to do is it's going to call a calculator that computes a payment, and the code wants to make sure that an exception happens because in this particular example, the principal amount is way out of bounds. Now this test passes, but the only problem with this test passing is that it asserts that the principal amount, incorrect spelling here, is not valid. So it asserts that the message coming back has to be spelled incorrectly, which means that when a developer fixes the code, they're going to have a failing test as a result. Well, more importantly, this specific text here is not necessary. It was not specified. It's just some developer said, oh yeah, in addition to it throwing the exception, I want it to say this. Well, this is actually not really a requirement. So they've overspecified the test as well. And so the two things I'll leave with you is, one is there's a great book called Specification by Example that shows how to build applications by describing using examples. And I commend to you this book. And then the second is that there should only really be one primary assert per your test. You want one primary assert, which in that previous code example was the exception. That's what he wanted to check, that exception occurred. The more your test starts to say, and it should do this, and it should do that, and it should do this, and it should do that, the more you will start to find that your tests become either overspecified or they don't isolate the problems very well. Obstacle number 2 is the idea of what I call the time crunch. That's the waking up, coming into work on December 1st, and finding a whole bunch of tests have failed. Right? The clock suddenly moved to a new date, and I've seen where tests fail because tests couldn't continue on past a certain date. They would start to fail. Or the code suddenly revealed a problem because the date moved forward. And so there are a couple of ways that you can fake time. A few of these ways include deploying to virtual machines and controlling the clock on those virtual machines, and see some people do that. The virtual machine doesn't have to sync up to the host. There are ways to isolate the system, testing environments that isolate the entire system from the operating system. And those are ways that you can do that. I talk about inspect the clock. What I mean by that is find a way to get involved with the developers in the areas where the clock is a factor. Right? Maybe more code review needs to be done there. Get the testing team to get involved in that. And so inspect the code that involves the system clock. And then the third one I'll talk about a little bit more in depth is the idea of a dummy iClock interface. So let me show you what that might look like. So the system under test might talk to the system clock through an interface of some sort. And here I've devised one called the iClock interface. So the developers will all program to this iClock interface instead of the system clock. And by default, it'll always point to the real system clock. But through configuration, it can be pointed to a dummy clock. And the test code can control that dummy clock. So the dummy clock might behave with an offset. Maybe you can specify it to go back 37 days. So your tests will always start from 37 days back. Or there are other ways that you control the dummy clock. So the test engineers or the software developers and the software developers can work together to come up with a way to make the system more testable in your automated testing system. So you're always creating the same scenario. Yes?
How would you control the library? So if a library, for example, .NET Framework is making a call for datetime.now,
Right.
how do you control that?
So the question was, if you're using a framework, how do you control what that framework calls back? So in this particular example, I'm going to call, in this code, I'm going to call everything not to the .NET Framework directly. It's going to go through this interface. So this interface would have something like a .now property in it that by default would return the datetime.now behavior.
I was just saying that for a lot of system calls might also want to use the clock property themselves.
Yes.
So you call some system function which internally calls the
That's true.
datetime.now.
Yes. I don't mean to make this sound too trivial, so it really depends on the system under test. So in some environments, you're calling one component that further calls into it. So you might have a third-party component, like a scheduling component, and you can't control where it gets that. So there are other interfaces you might have to build or other ways you might have to control that functionality. So this is not an end-all and be-all to it. What I'm trying to suggest to you is that the testability of the code that you write that directly interfaces, for example, if you're building a scheduling component, can be served by coming up with some way of decoupling from the clock directly in the code that your team is working on. So it's not a trivial answer, but it's something that I've seen as an effective way to overcome this obstacle. Okay? But I'll be happy to talk more about it with you afterwards if you want to go in more depth for that. The third obstacle that I've seen a lot is the database integration problem. When automated tests are calling into a database, they are looking for the database to be set up in a known configuration, known schema, known data, known metadata, all these other aspects. So one of the ways to address this obstacle is to try and come up with a fixture setup approach that creates the database. And there are a lot of things, schema migrations, products, and that will build the database and incrementally build it and add to it. And then the data sets that each of the different tests would use. The data sets might have specific scenarios that each one sets up the data for. And again, I don't want to make this sound like it's a trivial problem. It is a big problem. The virtue is that when your tests run, you have a clean database. It inserts the data set appropriate for that test. It runs the test, and the results are reproducible every time because it started from a known condition, a known set of data. If the data sets can be made small and easy to maintain, or relatively easy to maintain, then this can work very nicely. Usually, what I've worked with teams on is to come up with a little mini data set, maybe a few records, rather than hundreds of thousands of records. When they back up the production data, clean it up, restore it to the test environment, sure, you have hundreds of thousands or maybe even millions of records. But the test that you're trying to run in your regression testing may be reproducible with 3 records. That's what this is trying to do, is trying to isolate, reproduce the issue in a relatively small. So let me show you some tools to be able to do that. I talked about the schema migration tools like Roundhouse, FlyWayDB, Liquibase are commonly used. And on the data arrangement side, there are tools called DBUnit in the Java world, very commonly used, and NDBUnit in the .NET world. These are the tools that I've used. And what these can do essentially is create a database in a known condition before your automated test runs. Any questions on that so far?
Are those open source?
Yeah, let me talk about it. I don't know if all of them are open source. I know that DB-Unit and NDB-Unit are open source, free and open source. Roundhouse, I believe, is free and open source. I don't know about FlyWayDB and Liquibase, but I believe they are free and open source. I haven't used FlyWayDB and Liquibase, but I have used Roundhouse extensively. And some organizations write their own. Visual Studio has a way of doing these migrations. These are becoming more and more popular. For those of you who've worked in Ruby and Rails, you'll find this is something that's been done for quite some time. Any other questions? Okay. Obstacle number 4 is this idea of an explosion of test cases and test code. What I mean by this is that I've seen teams go one of two ways. They write few tests that are very long, or they write lots of tests that are really long. Either one turns out to be a problem. The reason this turns out to be a problem usually is because one prototype really long test is used and copied over and over again. And when that is copied over, it often has a lot of stuff that's not needed. So this explosion of test code means that you're maintaining lots of code. You might have 5 tests for every method you have in your Java class or your C# class. You might have 5 tests or 6 tests over here. And if those are really big, then you're maintaining a lot of that code. So we try and focus on getting a handle on the explosion of test code. So some of the things that I do and work with teams on is to control that growth by, first of all, let's monitor that. Let's find a way to actually measure the line of code or measure the ratio. Is there any way we can know the number of lines of code in the test modules versus the code that is the production code? Many testing frameworks now support the idea of parameterized test methods. You can data drive how the test operates, and that can cut down. So you have one test method, maybe testing 5 or 6 scenarios. That cuts a lot of the duplication down. And then the third thing is the boundary analysis. Oftentimes I'll work with QA testers or developers, and I'll sit down and say, you've got all these different scenarios, but how is 37 distinct from 38? It involves almost the same numbers. It doesn't really meaningfully change it. Why don't we have a test that does -1, test that does 0, test that does 1, test that does 27, and then maybe something that does 227. We'll try and do is figure out what the boundaries of those tests are and do a little bit of that analysis. So here's an example of some code that at the very top here is using some test cases, and it's driving the test which has 4 values: a principal amount, a percentage rate, a term in months, and then the expected payment amount. So each one of those test cases is calculated as an example in a specification. And the code, here's 3 lines of code instead of what might turn out to be 3 methods, each with 3 lines of code. So obstacle number 5, I often refer to this one as bad coupling. And oftentimes I'll work with teams and I'll look at their test code and I'll find that they are focused on a lot of the concepts that are important in production code. How do we minimize reuse? How do we modularize things? How do we create the appropriate relationships with things? in a lot of the test code, what you want to do is have things that are very isolated, so that if one test fails, it doesn't bring down 30 other tests. And oftentimes I've seen that happen, is where there will be a base class that will be called test base class, right? And everything will use it. And what will happen is somebody will throw something up there and it's a half-baked idea, and they'll use it and they'll say, oh, this should really go in the base class. And then somebody else will use this half-baked idea, and then they'll start using it. And then somebody else will say, well, that was a half-baked idea. Let me change how that works. And then 300 tests fail, right? The bad coupling is characterized by a lot of that type of reuse. It's also, there's this repetition of things, right? It's like the same method will do, test method, will do like the same 7 lines. And then you'll go in and you'll see the same 7 lines. And you'll see that type of thing repeated over and over again. And sometimes just simply asking the question, well, why is it like this? Well, when I copied that method over here, it had those 7 lines, and so I just continued having those 7 lines. So a lot of it is unhelpful repetition, because somebody later has to go in. As I like to say, grandma goes in and has to look at that code and understand it. You're going to feel bad about it, because nobody likes to disappoint their grandmother. And then the unhelpful coupling side of it, I talked about a little earlier, where you have one thing dependent on another. And these can get quite elaborate, these structures, where people try and get one test code coupled into another. And it turns out to be not very helpful at all. So I try and emphasize this point, which is test code is not production code. If you've done it right, it doesn't get deployed out into production. Some people will put the test code right next to the production code, and I don't think that's inherently bad. But it's written for a different purpose. And its purpose is to make sure the code works as intended. So oftentimes, it needs to be thought of as a different animal. So inheritance reuse is one thing that I often talk to people. Even though this is the database testing code, if you create the database test base class up here, then everybody who makes these tests are going to be coupling into that. And we'll try and avoid that as much as possible. What we'll try and do is we'll try and use some other types of ways of reusing things. And one of the things I talk about is context helpers, which is in the context of this suite of tests, maybe we can put some helpers into that, right? So across all the tests that you write, you might have one test that's right there. And it's to kind of keep it local to what test you're using. So if you're going to do some reuse, do something that's very local to that, rather than a big hierarchy. And in the end, the more you repeat yourself with the goal of just making sure that things are decoupled, the more you can encourage people who work on tests, whether they're part of the QA team or whether part of their development team, is that they should be ripping out code, right, that they don't need, because they have to understand that the test they just wrote is decoupled from every other test. So they should feel fine about pulling it out, that test method, because of this decoupling. Oftentimes I'll say, well, why didn't you just pull that code out? And they'll say, I didn't know if it was really needed for the base class. I thought the base class needed to call these things. They'll have some rationalization. But the more you try and teach them that the coupling is not there, we've taken that out of it, they can write these tests clean, the less that repetition. But again, repetition is better than coupling, so I'd rather have them do a little bit of repetition. But once they know it's not coupled, they'll be happy to pull out some of that code. So let me give you an example of test fixture. This class works directly with this test class. And what this will do is a number of things in very simple steps. This set of tests needs to set up the database. Has a very simple entry point. all it will do is set up the database for this one class it's working with. This second one is going to create some valid entities that this test needs. Again, it's very specific to this set of test classes. And then last, it's going to help me create an instance of this class under test. What I've got here is about 5 lines of code where if I actually looked into each one of these lines of code, I would find a lot of information about how instances are created, how the database is set up. But this test code is much easier to maintain because the person working with it knows 2 things. They know that the test context that this only applies to the test class that they're working on. And then the second thing they know is that the details of which they don't have to understand unless that's where the problem is. So usually what they're doing is they're focusing on the actual actions associated with the test and maybe some assertions at the bottom. And so the arrangement gets a little bit more simplified for them. So those are the basic obstacles. As I said, I put them up on the board there so that you can have them handy for notes. Any questions at this point? Sure.
You went into briefly in a couple potential roles on projects in an earlier slide, like the concept of UAT and or the designation of the role tester on the team.
Yes.
Looking across different types of the Agile practices from Kanban and XP.
Yes.
How does this model fit within, does there need to be a role of tester or across Agile? What are there skills required? It seems like you're looking through a lens of everybody is technical, can write test code.
So
That was a drawn-out question, sorry. Did you get
if I understand the question, the other question, as I understand the question, is on Agile teams, the roles and responsibilities, do they need to be drawn out into tester, developer? Do we have to have QA, engineer? How do we think about the role of the responsibility of testing and the roles that may or may not be found on an Agile team? Does that sum it up? So in some organizations, projects are everything. If you went to Boeing, for example, everything there is all about the project, as I understand it. And there are some organizations that are very functional oriented, right? And some like to think of themselves as very matrix. So in the functional organization, you'll have a QA department, and you'll have an engineering department. You might have a project management department. And some try to matrix those things in. So when I deal with organizations, I find that you'll have Agile practiced in various degrees. So you'll have QA folks that come in because they came out of the QA department. You'll have developers who came out of engineering. In organizations that are much more project focused, we've got an Agile team. And the Agile team is involved in all aspects. You'll have a business analyst who will be part of testing, and you'll have engineers, and you'll have people pairing up, and there's less identification in each of the different roles. What I like to think of is that when teams get together, they try and stay loyal to the Agile project they're on. Think of their loyalty there and try and put their loyalty there and work together. But I find it's often very hard for people not to think that they come from a functional group and have a functional responsibility. So I'd like, in general, to see people take on more roles and responsibilities and be more flexible about their roles and responsibilities. But I think some people see the hat that they wear as the only hat they're comfortable with. And so I see some variation from client to client. But I don't think there's a right way and a wrong way, because every organization has a different circumstance. And I can't bend them to the thing that I think would work well. But I certainly find that the more people get loyal to the project they're on and try and work in as many roles and responsibilities as they can, they do a lot better.
So you think that the concept, so that was a great answer.
Mhm.
Just maybe taking it one step further, so you think the concepts here that you've done, I mean, very well organized and seem to be very powerful, can be applied to any, you know, practice, or should or could be into any kind of organization that way?
So how applicable are these agile testing concepts to other parts of the organization? I think that's the question, right? Or
maybe is there an ideal environment that this stuff works the best in, and there's certain environments that it's more challenging in?
yes, I would say there's an agile maturity continuum, I'll call it that, right? So there are things that when I've been in organizations, I practice what I called agile, guerrilla agile, right? And where basically the organization said, we're not interested in agile. And I said to myself, you know what, agile is all about teamwork, people interacting well together, people collaborating, focusing less on methodology and more in delivering software. Maybe I'll just do some agile things, but really do it in a guerrilla way, unconventional warfare style. Not to use too many military analogies, but that I think is certainly not a place that promotes agile. Then there are other organizations that really want to do agile, and it's often because there's somebody who's championed it. I recently worked with a client where somebody from the organization is now the director of product development for that organization. And he came from another organization, came in, and he worked with his team, and he wanted more of them to get the vision thing. So I went and did a workshop with them. And he had exactly what he was trying to do. So there, I will call that more of an evangelist type of thing, where the people were really trying to adopt Agile and that type of thing. They're further along that continuum. And the organizations that really have Agile well under their belt, they don't call me, because they're already practicing the best practices and they're doing a lot of that stuff. And then the other side of the continuum is what I call sort of the Agile in name only. And they're the ones who you come in and everything they're doing is waterfall, but it's got an Agile label on it. So it, for all intents and purposes, is not Agile. And they're not on the Agile maturity continuum. So, but it's a good question. Thank you. Yes?
You mentioned about the explosion of test code and
Yes.
talked about the ratio of test code to
Yes.
actual production code. Do you have a rule of thumb or some kind of guideline?
A golden ratio. I do get that question a lot, and I would like to say a rule of thumb is I look for about 5 test methods for every method of code. So if I have one function over here, I look for about 5 or 6 over there in the test suite. And what I like to see is maybe just 5 or 6 lines in each one of those. If I see dozens of lines in each one of those test methods, I'm going to try and figure out how those might be collapsed. That's a rough. Now, I have gone into some environments where I've seen that they're doing a lot of test code. And I say, this accounting problem you're working on, this depreciation thing, that's a really deep domain. And it makes sense that your depreciation calculation engine has a lot of tests. And so I will definitely back away from any of those type of metrics as I look at the domain. The deeper the domain, the more that starts to look at, oh, you've got 17 dimensions here, and each of those dimensions can vary widely in its parameters. There can be a lot of those tests. Now, I might start talking to them about how do we data drive these tests? Have less code, more spreadsheets. And maybe those spreadsheets can be formatted in a consistent way. And the accountants say, oh, you mean we just write up these things in spreadsheets? And pretty soon, we're moving away from the code and into the parameterized data-driven side. Does that answer your question?
Yeah.
Okay.
I mean, I would imagine that, from what you said, if you're just looking at lines of code, you're going to have more lines of test code than you are going to have more lines of.
Typically, I will see like 5 or 6 times as many methods. I am not trying to explode the lines of test code. If I could do one line of test code that give me 100% coverage, I would go for it. But I'm often looking for that. Now, test-driven development, for example, can often create a lot of tests. And I'm not saying lots of tests are inherently bad. What I'm saying is that over time, you might want to look at your tests that you wrote in your test-driven development and figure out how to refactor them. How can we reduce the number? How can we come up with a different format? So I certainly honor the test-driven development side of it, and I definitely practice that whenever I can. But oftentimes I'm brought into projects and says, we have this mountain of production code that we'd like to test. And we'd like to take our brownfield application and now use Agile to go forward with it. You know, after we've had 10 years of development with it, we're finally ready for Agile. So I'm oftentimes coming in to those folks and talking to them about that.
Good luck.
Sir, go ahead. What's your question?
So if you have a new team, new to test-driven development or Agile, even let's say new to Agile, what's the first set of engineering principles that you introduce to them to get them moving in this direction?
So some of the first things that I will talk to a team that does not do Agile testing at all is I will talk to them about a couple of things. One is the tests that you write will help you debug the software. And I was talking to one engineer, and he was very skeptical about test-driven development and writing tests and things. And I would say, well, how are you testing? How do you debug it right now? Well, I go through the UI and I do this and I do that, and 15 minutes later, I hit the breakpoint and now I'm debugging the code. And so I said, well, would you like to learn another way? Maybe do that a lot faster. And we sat down and we used NUnit as our testing framework. JUnit would work just as well, but this was a .NET application. And we put a breakpoint where he wanted to debug. We called the method directly that he wanted to debug and created all the initial conditions. And in a lot less time, he was debugging. And he said, wow, this would be so much easier for all my junior people. And I said, why? He says, we have to spend so much time teaching them about the UI and all of this other stuff, when what we really need them to do is go in and fix this bug in here. And we want to be able to do that. So that's one principle I teach is to the engineers, is get involved in it just for the debugging. The second thing I do is I try and teach them about taking passes at testing. So as a developer, when I sit down and say, as an engineer, so try and do it as passes. When I work with QA teams, I say that the same thing. Say, let's do one test. They'll say, just one test? And I'll say, yeah, but we're going to do it through an automated build process. So we're going to automate the build, we're going to automate the deployment, we're going to automate the configuration, we're going to run our one test, we're going to automate the generation of the report, and then we're going to automate the delivery of that report so the project manager can take a look at it. And I go, oh, well, that's a pretty big one test. Well, that one test sets up so much more after that. And I'll do the same things with the developers. They'll say, let's just write one test. And they'll say, just one test? And I'll say, yeah, but we're going to do it for every module. And I'll say, well, every module is really complicated. And I said, no, we'll just write one simple test for every module. By the time we're done with that, usually I'm dealing with a team lead or an architect, we'll have created all the projects and all the conditions. And then it's real easy for them to go out and teach the other developers how to write the second test in that module. But it's usually the problem is nobody's written that first test. And then I'll say, okay, we'll write one test per class. And so I kind of coach them through it that way.
Great.
Yeah? Sure.
So what I hear so far, I missed the first 15, 20 minutes of it, so you
Okay.
forgive me if you covered it. your audience here is the engineers. From my point of view, I've come across projects which have many of the symptoms you've already mentioned. And one of the first things I look at, because I'm coming at it from an engineering point of view, I do testing, but I do the development work. One of the first things I look at when I inherit a project is the test coverage. And usually the test coverage or lack thereof is an indicator of poor management. So when I see something like that, you've got to obviously educate the engineers, but you've got to have the backward kind of pressure being put on management to say, well, like, how the hell did we get here? Because we've got 2 years of development and we have 0 test coverage. Like, this is terrible. And then you have all sorts of other things that come in there as well. So like, for instance, if I saw an explosion in test code, I'd almost think that's a good thing in some cases. Because at least people are doing it.
That's right.
But, you know, and then you could educate them and work on that. But then the trouble is with a lot of these projects is that you get into a situation where people have deadlines to meet, which are in many cases unrealistic. And so they start to cut corners. And one of the obvious places to do it is testing, because at the end of the day, if you have 100 tests but not functioning software, that looks really bad.
Yes.
Whereas if you have functioning software and say 10 tests, that looks like kind of okay, for a management point of view at least. So I don't know, like, what's your opinion on that?
So I deal with management all the time, believe it or not. That's a lot of...
I'm kind of taking for granted that you do.
So here's one of the questions that, and we can go into more depth at the end of it. So the question is, let me see if I can sum it up, is that many times the testing, especially the testing done by the developers, is not done because management doesn't support it, right? And so oftentimes I'll work with the management up front, if I can. And I'll say, how do you know that they're writing good code? Right? How do you know? I mean, if you went and bought a car and the car said 0 safety rating, are you going to buy that car? Or are you going to buy the 5-star safety rating? Somebody's told you that that car has a 5-star safety rating. And they've told you that has a 0-star safety rating. Right? But what does your code have? It has a question mark safety rating, right? Nobody knows what you're getting. And usually management has no visibility. So usually what I'll talk to them about is visibility and indirect measures of quality and indirect measures of progress, right? And so some managers will say, you mean I will get some insight that I've never had before into what's going on? I'll say, yep. I'll say, you'll have code being written over here and tests written over here. And if your tests are flatline and your code is exploding, then your question mark is just getting bigger. So some managers want to control quality because they realize that those defects are going to be found. They're going to be found somewhere. Usually, if you're not monitoring quality, they'll be found by the end user. The end user will say, your software is broken. One way or another, that's what they're going to say. It doesn't meet expectation, or it just plumb doesn't work, or it gave me the wrong result. The more managers are connected with the fact that they don't want to be doing that, the more they're looking for ways to stop it from happening. And those are the conversations I'll have them. So I'll talk about insight and visibility and those types of things. I'll also talk about what are some of the things that they're having going wrong. They just don't know that it's possible to have developers not manually deploy things for 40 minutes every time QA wants a build and come up with a continuous integration solution that deploys it in 20 seconds without a developer being involved. You mean I don't have to pull a developer off of what they're doing for 40 minutes to go manually deploy the system and misconfigure it, by the way? I can actually have a continuous integration server run a deployment script that is right next to the server. It's on the T backbone, you know, and it'll deploy the whole thing in 20 seconds and configure it properly, and I don't interrupt my developers. And my QA folks are like, I didn't waste my time with another bad build that was misconfigured. Right? Those are the types of things managers say will save them time, will save them money. Those are the conversations I have with them about automated testing, about monitoring testing, and those types of things. Not all those conversations go well because ultimately some of them say, you know what, if there's a defect in there, let the users find it. I just really care about being on time and under budget. It's like, okay. we're probably not going to have a great conversation about improving quality in your application. So hopefully that gives you a sense of the answer that I experience anyway to that question.
Did you have any experience with performance unit tests that do performance monitoring or performance testing? Like if you expect a method to execute with the known data set, execute in like say 2 seconds. So
Yes.
how do you put?
So I'm not going to get into it right now, but maybe at the end we can talk about it. But most testing frameworks have performance characteristics. So part of whether the task passes or fails depends on how long it ran. So if it ran too long, and some of them even have a little variability. It ran at no more than X, or it ran between this and this, or something like that. So there are those types of things that are built into the testing frameworks. And engineers should be able to dig into those testing frameworks and find those answers. But most of them have that facility. Yes. Any other questions? Okay, let me leave you on one note. If I built this bridge, I would run out to the middle of this bridge and I would say, come on. It works perfectly, right? But if another engineer walks up and says, go ahead, you first. Right? You never trust an engineer who's not willing to walk over the bridge they just built, right? You want to have the whole team committed to quality. You want the whole Agile team to run out to the middle of the bridge and swing it back and forth and say, come on! Right? They're either idiots, but they're convinced that what they've built is working as intended, right? That's the kind of confidence that I usually see in Agile testing and the teams that do Agile testing. The developers who've tested their own code and make sure that it works as intended have a lot more confidence. They go into requirements meetings and say, yeah, I know my code works. They're not cocky because they're cocky because they've tested it and they're confident. A little shameless self-promotion. I wrote a book, for those of you who don't know. It's called Pro.NET Best Practices. And a lot of what I've learned over the years about Agile testing and best practices in the .NET world, I put into this book. I would like to have made it bigger, but that would have taken a lot more time. But I try and put many of the ideas. The key is you want to try and avoid making the same mistake once. And I've already made the mistake, and others have already made the mistake, and hopefully you don't need to make that same mistake. If you want the code and slides, the code to my book and the presentations that I do is up on Ruthless Help, which is my Twitter handle, @RuthlessHelp. Hopefully I'm more helpful than ruthless, but you'll be the judge of that. And you can find these slides on slideshare.net/ruthlesshelp as well. And if you want to contact me, you can email me at steven.ritchie@excella.com or Twitter @ruthlesshelp, or my blog, ruthlesslyhelpful.net, or my LinkedIn, I'm in/sritchie. Okay? As I said, I'll be here after the presentation if you want to chat, have any questions. So thank you all.
Thank you very much.